One of the things that's tripping people up the most is dealing with tangents and cotangents on the unit circle. I think because we've sort of like fallen into the algorithm of knowing that sines are the y-coordinates and cosines are the x-coordinates. But that's like an oversimplification, so we got to go back and remember why. If we draw in a triangle right here, and look at what this looks like, you've got your angle in this corner tucked up against the center, and then your hypotenuse is, of course, this long side. It's always equal to 1 on the unit circle. That's why it's called the unit circle, the UNO circle. And so then this side over here is your opposite side, and this side here is your adjacent side. Now, the O, the opposite side, is vertical, and so the opposite side corresponds to the y-coordinate, and the adjacent side corresponds to the x-coordinate. So what that means is, at any point in time, instead of having to go back through and think through all of this, like if I want to find sine of some angle, every time I see an opposite, I can use the y-coordinate. Every time I see an adjacent, I can use the adjacent coordinate, the x-coordinate. And every time I see a hypotenuse, I can use the number 1, instead of having to actually like draw out a triangle, figure out the side lengths. So this is going to save me a ton of time. So, for an inverse trig problem like this is saying tangent of some angle is rad 3, and I don't know what the angle is, but I gotta find it. There are so many ways we can do it. One of the easiest is just by like guessing something and plugging it in. So, let me guess, I'm gonna do 3 pi over 4, this one right here. Negative rad 2 over 2, 2 over 2. Okay, so just as a reminder, tangent is opposite over adjacent, so we're gonna check and see if theta is equal to 3 pi over 4. And we'll do that by taking the tangent of 3 pi over 4. And so to get that, we're going to do the opposite over the adjacent. Okay, opposite, remember, is the y-coordinate. So in this one, the opposite would be rad 2 over 2. Rad 2 over 2 over the adjacent. And remember, adjacent is the x-coordinate. So in this case, that's going to be negative rad 2 over 2. Negative rad 2 over 2. Okay, looking at this, I see same thing over same thing. So this whole mega fraction is actually going to reduce to a negative 1. So, in this case, actually, my first guess, tangent is 3 pi over 4, is not correct. Okay, I need to try something else. I guess now that I see this, I recognize it has a rad 3 in it. So I want to try something that has a rad 3. I think I'm going to end up with one of these, because I also don't want it to be negative. I got negative numbers in here. Since this is positive, maybe I'll stick up here. So, let's try pi over 6. So then, to check and see if tangent is of pi over 6 is what I'm looking for. I'm going to use the same process. Tangent is opposite over adjacent. So the opposite coordinate is 1/2. And the adjacent coordinate is rad 3 over 2. And this one I can't remember off the top of my head, but I do know how to deal with 4-tiered fractions really well. It's just, you guys have used copy.flip, so I'll use that since that's what you're familiar with. It's going to be 1/2 dot and this upside down, so that'd be 2 over rad 3. Switch that all together, I get 2 over 2 rad 3. The 2 is reduced, so I get 1 over rad 3. I'm going to rationalize that, which you guys are really good at doing. And I get rad 3 over rad 9, which is rad 3 over 3. I am for sure the closest I have been yet to the answer. I'm looking for a place that tangent of theta is equal to rad 3, and in this place I got rad 3 over 3. So I still didn't get an answer. See if you can figure it out. That's not right.